Let's get started. We warmly welcome you all to the third OpenChoreo community call. And just wanted to open the floor if there are any new joinees, if they would like to introduce themselves, we can have a few minutes. Let me open the floor for anyone who has joined newly to the OpenChoreo community call and would like to introduce themselves. So, since there's not much of a reply, we can get started with the session. So, today we have a very interesting lineup. For the community out there, we have just released 1.2 version, and today we will have a release walkthrough of the 1.2 release. And then we have some interesting sneak peeks of various features and capabilities. We will be covering the sizing guideline for installations, and we will also show and discuss about the release resource tree improvements. And we'll also take you through any improvements and new outlook of the read-only playground. And as we always have, a code walkthrough for external contributors who want to contribute to the source code. And for the code walkthrough segment, we have the walkthrough on the gateway modules. And then we will open the floor for any questions. Also, the floor will be open for any discussions of features or any other points that anyone from the community would like to discuss. So let's get started, and Mevan will take us through the release, the 1.2 release, and any interesting features that came out, and will give us a high-level intro about the features. Over to you, Mevan.
Thank you, Kaushika. Share my screen. Can you see my screen?
Yes, we can.
Okay. So, hi everyone. I am Mevan Karunanak. I'm an OpenChoreo maintainer from WSO2. So today I will walk you through what's new in OpenChoreo 1.2 version. So if I were to sum up what we have delivered with this release, mainly the matured release management from component level to project level, and some major improvements in the observability side and day-to-day developer ergonomics. So let's check out what those new features and improvements we have delivered with this release. Uh, Okay, so when it comes to this 1.2 release, the headline feature we have delivered with this release is this project level release lifecycle management feature. So up to now in OpenChoreo, if you wanted to release something, you were releasing a single component. With the new project type, project release and project release binding CRTs, you can now version and promote an entire project as a unit. In this feature, we are using the same concepts and underlying design used for component release lifecycle management, making this feature user-friendly and based on our basic principles. This feature is now fully integrated to OpenChoreo end-to-end, making it working across the API, the portal, and CLI. And also, it's even exposed through the MCP if you are driving things through an AI agent. So this is the key feature that we delivered in the 1.2 release. Then we have this terminal access to running components. So this is also a feature that developers have been asking for a while, interactive exec into running components. Now you can open a terminal into a running component from the OpenChoreo portal, the API, or the CLI, and do your debugging at the container level. Also, in here, I need to highlight that this isn't kubectl exec for everyone. So in here, the access is always conditionable, and you have the capability to restrict where this is allowed, and you can optionally target a specific pod rather than getting dropped into a arbitrary one. So this feature is also something that we have built with the same access control mindset and provide a uh, very important capability for the developers using the platform. Then I have, as I said in the beginning, so we have done some major improvements to the observability side as well. So in 1.2 release, we have done two major additions to the observability side. So first one is the Kubernetes events. So Kubernetes events are now collected in the observability plane and they are queryable through the observer API. So that means like events previously that can only be read from the Kubernetes cluster itself are now part of the OpenChoreo observability story as well. Then the wire logs. So wire logs is also a major feature we delivered with this release. So this comes with the Cilium module that we have delivered. So this is the Cilium Hubble network flow log data that we are streaming through an API, and this can be directly visualized in the Backstage UI. So I need to highlight that if you have ever had to chase down a network level issue between services, this means you can do that in investigation within the OpenCoreo portal itself without going out. Then I need to highlight the governance and guardrail improvements that we have delivered with this release. So mainly there also we delivered two major improvements there. So the first one is we have introduced new ABAC conditions on a new set of OpenCoreo resource types. So mainly the resource type resource and the component type resource and the workflow resource. Now the platform engineers have the capability to fine-grain the access control, who can do what on which component as well with this improvement. Then we have introduced again this cell validations support for pre and post rendering component type and plate resources. So this also adds the value of like catching any bad configurations or any misconfigurations before it ever enters into the live resource. So this is about the governance and guardrail improvements. So other than this, so those were the major improvements that we have, major improvements and features we delivered with this release. Other than that, I need to discuss about like some other features and improvements we delivered with this release. So the first one is this portal and developer UX. So in that area, we have delivered this API tryout console where like developers can try out their APIs through the Backstage portal itself. And we have also bundled agent-based component creation wizards into the portal itself. So now the agent-based component creation flow is users can smoothly do the agent-based component creation itself. So, and also we have done some improvements to this release and deploy page designs. So mainly a redesign where like you can see what's the actual diff between the current deployed artifacts in a given environment and the artifacts that you are going to promote into that particular environment. So in this view is very useful for someone who's trying to promote some set of changes, what to verify that what actual changes are getting updated in the current deployment. So and also we have done some improvements to WCAG 2.2 AA accessibility conformance as well with this release. And when it comes to platform and infra level improvements, mainly we have done this Gateway API version upgrade to version 1.5 with the Nginx Gateway Fabric. And also we have done an improvement to like separate out the cluster gateways, internal and external APIs. So now the earlier these both of these APIs were exposed through a single API. Now we have separated it out and we have introduced MTLS uh, for this internal as well as external traffic as well. Then also we have done some improvements to CADA-based scale to zero auto scaling as well. So we have released a community module based on this and improvements related to this. And regarding the installation experience, we have done some improvements on single command K3D installation. So like earlier, you had to follow like a lot of steps to do a K3D single cluster setup when you are installing the platform. Now we have smoothened it out and provide you with a single uh, shell script, single command to get the installation done. And also we have added support for this air-gapped Helm installation as well with this release. And additional to that, regarding the build and CI pipeline, so we have introduced this build cache support. So this allows for faster builds. So those are the major improvements and features that we have delivered with this release. So if you have any questions, so I think I'm happy to answer.
Thanks, Mevan. So next we have Rashad who will take us through the sizing guide for the installations. Over to you, Rashad.
Yeah, hi, thanks Kavishka. And yeah, and today like I'll be going through the sizing guide for OpenCore installations. So this is like one of the most like one of the friction points when you want to install OpenCoreo and onboard your apps into OpenCoreo. So hi, I'm Rashad, a software engineer at WSO2. And yeah, so like before you install and onboard your application, so we have like three main questions like, so what do I provision? So for example, like okay, so I have the OpenCoreo cluster and I want to install it. So like how much resources do I need and like how many node pools, quotas and so on and so forth. So we need some number to get started. And also like as we go on using the platform, our usage grows. And so when that happens, we had to be mindful of like what would grow in the platform or like in our workloads, and we had to be mindful. And then we also need to see like where we need to give our attention so that we can be ready. So yeah, so in OpenCore we do have four planes, and all these four scale in a particular way. So let's start with the control plane. So this is basically like where all the planes are coordinated and all the CFs are managed as well. And so we do have the backstage portal, which the developers and the platform engineers will be using, and then the API servers and the MCPs and so on. So when it comes to sizing, this doesn't scale that much because it's basically just reconciling a bunch of YAMLs plus whoever is using our platform through backstage or MCP or even agents. So these can be the developers and the PEs and the agents. So like there really isn't much to think about here when it comes to scaling because it's like most probably it's like enough for you like no matter like what workloads you have. And then the workflow plane. So yeah, so I rather go to the data plane next. So the data plane is basically your own workload. So like whatever you deploy on OpenCoreo goes into this plane, and the platform overhead in the data plane is basically very minimal. So we have a bunch of cluster agents, like a cluster gateway which like handles all the coordination. And then we, if you have the observability plane installed, we would also have some exporters as well. But in addition to that, it's basically your workload. So you should size according to that. And then the workflow plane, it is also so it's kind of tricky when it comes to sizing because like so this is basically where your workflows and builds run, and the build pods are like they exist and then they are gone. So which means like during peak hours, like when your developers are working, like there can be like lots of builds in the same time, and then like we might need like lots of resources. And during off peak hours, so we might not have anything at all. So like if you over provision, that will be a waste of money. So here like the suggestion is to just calculate and like an average number of builds per hour and size according to that. And for the peak, we can let node auto scaling handle the rest. And then the observability plane, again, it's like very tricky to scale for because again, like it depends on two things. So in OpenChoreo, we do have many options when it comes to observability. So some of them are self-hosted and some are cloud-based. So when it comes to self-hosted observability planes, so the whole observability stack runs on your cluster, which means the you would have to account for those when it comes to sizing as well. And then the cloud-based ones. So these are basically at this point the observability plane is just a query layer which like queries the cloud API and gives the data for you. So then it's again like kind of straightforward. So and when it comes to self-hosted observability planes, it's like really tricky because again like it depends on like how much, let's say for example logs, like how much of logs are like exported to the plane like per minute and the size of it and like your retention period and so on and so forth. So like there are so many variables to consider about, and so in these cases we do suggest to refer the particular modules sizing guide. This is a third party module, so like we can consider their sizing guide as the sizing for the observability plane. And in addition to that, the OpenChoreo overhead is again like not much in here because here in the observability plane we have the observe API, which basically the portal queries. So it's again depends on how many people use it, which is not much. So that's that. And also for the workflow plane, in addition to the builds, we also have the controllers again, which isn't much to be concerned about. So that's like how sizing works. And let me go through the sizing page as well. So here basically we have like what are the factors that come into that we had to consider when it comes to sizing. And so what I wanted to show you was, so we do have an Rust estimate, a calculator which lets you estimate how much uh, compute you need. So this is not like a very exact figure or such. So this is like just to get you started. And again, sizing is just an exercise with like back and forth and so on. So here basically we can see like how many components we do have and the how many environments, and then we could pick the planes that we need, and it would give you some number to start with. Like for example, let's say I do have around 70 components across three environments, and so this suggests that I need this much of CPU and this much of RAM. And then again, so the workflow plane, so we do the max builds and the average builds, so this is per hour. And also the observability plane, so if it's open search, which is self-hosted, as you can see the observed plane, it's a lot. But like again, like if you just go for example Azure, like it becomes very little. So you can't even see the footprint over here. And also this is like built on a bunch of assumptions which you can just go through, but so it's basically a good starting number in my opinion. And yeah, thanks a lot. Handing over back to Kavishka.
Thanks, Rashad. So next in line, we have Chaturanga, who's going to cover about the release resource tree improvements. Over to you, Chaturanga.
Thanks, Kavya. So I'm Chaturanga. I'm also an OpenChoreo maintainer from WSO2. So today I'll be talking about this improvements to resource tree. Uh, if you're already familiar with the resource tree, it's shown on the deploy tab under component. So what it shows
Chaturanga?
is
Sorry, Chaturanga, I think you're not sharing the screen.
so, so, uh,
Yes, now we can see it.
so this is the screenshot from resource tree view. So there from left to right, we first have the release binding resource, which basically responsible for deploying to the environment. After release binding resource creates a rendered release resource, which contains all the rendered Kubernetes manifests. Those gets eventually applied into the data plane. So we show them the next. This is a service component type. So we have deployment, config maps, those types. So We also show the pods created by the deployment, depending on the component type, which gets shown here will be different. So let's talk about the limitations we have. So this is again the beam screenshot from the size component type. So if you are already familiar with how Kubernetes deployments work, deployment controller creates a replicas child resource, and in turn it creates multiple pods. So because this resource tree was kind of hard coded into how we discovered child resources created after the rendered release, we directly showed the pods created by a deployment. Also, we are using external secret resources for resolving secret values from keywords. So in this case, the external secret also didn't show the actual Kubernetes secret resource created in this view. So developers didn't actually have any idea whether it was resolved or not. So also, this is from a component type provided by the agent sandbox module, proxy AI agent component type. There, that component type uses sandbox claim kind as the workload type. So sandbox claim controller doesn't directly create pods. Instead, it creates a sandbox kind, then it can create the relevant pods. So there we didn't have any hard-coded or anything resolving that part. So it was sandbox claim was shown only as leaf node. So as for this improvement, we have decided to give the platform engineers the flexibility to define their own roles for showing on this resource tree. So to do that, we have supported two ways to discover child resources. Main one is the ownerf. So if you're familiar with how the ownerfs work, for example, deployment creates replica sets. So under replica set resource metadata, it has its owner resource defined. So that way we can discover which inland got created. So in some cases, operators don't really use owner references due to some limitations. So for that, we have supported label selector attributes. So by default, we plan to ship some rules so that you don't have to repeat common ones. So major is the deployment replica set pod relationship. Also, we are adding rules for cron jobs, and external secrets. Secrets is a bit specific because we are omitting the secret content due to sensitivity. This is part of what we plan to ship by default only for the deployment kind. Now, if you want to add support for other resource kinds, this one is again a sample from the agent sandbox module. So here also sandbox claim kind is related to sandbox. Then we define the relationship to pod as well. So to do that, Ps can add this configuration into hidden values. So it don't conflict with the default ones. They have the option to disable the default configuration if they need any customization as well. In addition, they have to define the RBAC configurations for these kinds and grant them to the cluster agent, because in the end, the cluster agent has to fetch these resources from the other planes such as data planes or observed planes. Now I'll switch to demo to show how this gets shown as this. So I have deployed a deployment service component and a proxy AI agent component in my local cluster. I'll just go to the deployment now. And here in the resource tree, you can see the release binding, then the rendered release, and external secret has resulted in a secret resource here. So if you go to the definition, it just shows the metadata because you can't actually show the content. As to the deployment resource, we have shown the replica set here. And so in this case, it was only deployed once, so there is only one replica set. After we have the pods created by it. So that's how the service component type is shown here. Then I'll go to this AI agent component type. So here, again, the rendered release resource has emitted the sandbox claim resource. So you can see how it has created a sandbox and pod resources. Yep. So yeah, that's how it works. It's just a screenshot from CNCF. Yeah, so we'll actually document it before releasing and provide full guidance on how to configure it. Yeah, that's about it.
Thanks, Chaturanga. So next we have Isela, who will cover the read-only playground. I think that's some feature that you all would have tried through our website as well. So over to you, Isela.
Yeah, thank you. Hi guys, I'm Isala. So I'll be showing off the new upcoming read-only playground. So like if you guys have used our existing playground, as of now we have this hosted server where you get a dedicated VM for about an hour to play around with OpenChoreo, and you get your own backstage console and everything. But there has been some request around like you have to authenticate to experience Choreo, and like there is a wait queue sometimes. So we have been building this read-only backstage portal where you just get access to the OpenChoreo console, and you can experience OpenChoreo from here. So we have the project already preceded with few things. And if I go to, let's say, URL shortener, I can see all the components that are running and what are the deployed and what are the failures. And I can go and explore new features like the project, Mevan explained the project-based promotion thing. And we have the new cell diagram as well, and you can check the observability data and see how the traffic flows between application and understand architecture. And we have the system diagram as well, and we get the project level logs here as well. And we can of course go to like different components and get like their information as well. For example, if I open the front end, I can see there is a build that was successful 10 hours ago. I can check their logs, and yeah, and but all the write actions are prevented, so you can only do the reads to this. And if you go, you can see the logs, metrics, and even the feature that was mentioned by Mevan. You can get wire logs as well, and you get the so these components continuously get traffic, so you can see the HTTP like raw data from Hubble, and you can explore the concepts like the namespaces, projects, and everything. So, and you can even like try out how our creation workflows works within our cluster, but you can't like create anything. For example, if you want to know how to create a web app, you can go here and just go through the process, but and understand how things works before you commit into like run it on your own cluster or like on your environment. So you can get a very good idea what OpenChoreo has to offer. So other than that, we had updated our demo site to version 1.22. So if you log in now, you get the version 2.2 cluster, and with this version, we have installed Cilium here as well. So Cilium would be the default CNI that would be running, and you get the HTTP level telemetry as well. So if you are familiar with the like our old playground, we have all these features. You get your own thing, and you get kubectl access, and you can delete or whatever. And for 1 hour, this box is yours to keep. So yeah, that's how it is. And if you guys have any more requests, like send our way, we'll always try to do our best to like cater them.
Thanks, Isla. This is absolutely great, right? They can get a full glimpse of like the platform and really understand before really committing into or going that extra mile of really installing it locally and checking it out. So this is a great walkthrough for them to really try out OpenChoreo in itself. Um, so next we have Lahiru, who's going to take us through the gateway modules code. So this is an interesting segment for all the external contributors who want to contribute to the code segment, and especially anything related to the gateway side of the code. So over to you, Lahiru.
Yeah, thanks, Kavishkas. Let me share my screen. Can you see my screen?
Yes, we can.
Okay. Yeah, hi guys. So I'm Lahiru Silva, and I'm also one of the OpenChoreo maintainers from WSO2. So in this session, I'm going to talk about how we have utilized the Kubernetes Gateway API to build the modular API gateway architecture of OpenChoreo. So yeah, so by default, like OpenChoreo core does not contain any API gateway source code or any other vendor specific gateway configuration. So one of the main design principles of the gateway architecture is to have a very modular architecture in OpenChoreo so that different platform engineers or like different organizations can have their preferred gateway technology integrated with OpenChoreo core. So due to those reasons, we haven't included any gateway configurations in the OpenChoreo control plane or in the OpenChoreo source code itself. But we have designed an architecture where we can plug any Kubernetes Gateway API compliant implementation to OpenChoreo. So if you look at this diagram, in the diagram you can see in the control plane we have the OpenChoreo abstractions like component type and threads. So these are like native OpenChoreo abstractions, and inside these abstractions you can template different kind of Kubernetes resources. So in the diagram, if you look at this data plane, in the data plane you can see like there are no any gateway like no any vendor specific resources in the data plane. So like this HTTP route, gRPC route, and TLS route, all these resources are standard Kubernetes Gateway API resources. So like if you look at this pluggable sky here, so like here, like these are like modules. So in the module you can have any vendor specific logic. So for example, when you install some gateway API implementation, like there will be some gateway controller and the actual runtime. So likewise there will be some vendor specific implementation. So we have used this OpenChoreo component type and threads to abstract away the vendor specific implementation, and then like as platform engineers they can template different kind of Kubernetes Gateway API resources along with vendor specific resources, and then they can integrate their preferred API gateway to OpenChoreo core. So Yeah, so this is the typical experience any platform engineer or any developer would have in OpenChoreo. So initially, they will have to install some API gateway. So in the default installation, we already include K-gateway as the default gateway. And then after installing the gateway provider, you have to register it in the control plane. So here, registering the gateway provider means just providing some basic information like which namespace the gateway is running and the gateway class. So some of the very basic information there. So those information will be there in the data plane custom resource, or you can have it in the environment custom resource as well. And then once a platform engineer installs some gateway and then configure that gateway in the control plane, the developers of that organization, they can deploy applications to the cluster, and then they can expose their applications using that gateway. For that, the platform engineer has to template some routes like HTTP routes, gRPC routes, some routes that are coming from the Kubernetes Gateway API into the component type templates. And after that point, if some developer wants to use some vendor specific features of the gateway like security, authentication, rate limiting, so for those vendor specific policies, then the platform engineer also need to write some clustered threads or some threads, and then the developer of that organization can attach those threads to the components, and then they can use various gateway specific features. So yeah, so this is the initial stage. So the platform engineer basically has to configure the gateway. So this is the gateway CR that is coming from the Kubernetes Gateway API. So here, this gateway class name is this gateway class name represent the gateway vendor. So from the OpenChoreo control plane perspective, we only need this gateway class name. And then in the listeners section, the platform engineer can template different listeners. So for example, here, like there are 3 listeners. So based on the requirement, the platform engineer can template different listeners. And also, since like in OpenChoreo, when you deploy components, those components will get deployed into a cell namespace, in like a separate namespace. So for that, you need to have these allowed routes, and in the namespaces section, you need to say from all. Otherwise, you will have to provide a list of namespaces where that HTTP routes can get attached to this gateway. So, and this is the place where the platform engineers need to register their gateway provider. So in the data plane environment, like I said previously, you can have the name, namespace, and the listeners of the gateway. So this information will be used by the control plane when the control plane tries to resolve the invoke URL, like after you deploy a component and after you expose that component via the gateway, you need to have an invoke URL to invoke that from outside. So for that, the control plane will use these listeners and the ports. And yeah, like this is how you basically template HTTP routes in the component. So in the component, we like from OpenChoreo side, we provide some set of cell APIs like endpoints. So like you can have access to different informations of your workload like endpoints, and based on those endpoints, you can template different routes like HTTP routes, gRPC routes. And like here in the HTTP route, you have to specify the parent ref. So this parent ref is how this HTTP this HTTP route will get deployed to some gateway. So here in the parent ref, we have to define the correct parent ref of the relevant gateway. And here also, like we from the OpenChoreo cell APIs, we provide some gateway, like we provide some set of APIs that you can use. For example, here, like if you say this here in the parent ref gateway.ingress, then the HTTP route will get deployed to the ingress gateway. So likewise, there are a set of different gateway hierarchy. And this is an example of the trade. So like I mentioned previously, Kubernetes Gateway API does not cover the vendor-specific policies or the authentication or the rate limiting like policies supported in a gateway. So those are provided by the vendor. So for those use cases, the platform engineers need to define some trades. And then in the thread you can have like this creates, patches and removes. So here in OpenChoreo, like we have the concept of components and then threads. So you can use threads to provide additional capabilities to components. So here in the thread definition, you can create additional resources, or like you can patch some existing resources in the component, or you can remove different resources in the component. Yeah, from a developer perspective, so basically the developer intent, the developer will define the visibility of the endpoints that they have in their applications, and then based on the visibility, it will render some HTTP routes. So for example, if you have internal gateway, then it will have a HTTP route which get deployed in the internal gateway, and if the visibility is external, then it will have a HTTP route which get deployed in the external gateway. Yeah, so this is one of the concrete templates of a HTTP route. So this in this, like you can see, you can access different macros. Like from OpenChoreo side, we provide set of cell APIs and also set of macros, which are basically like functions that you can use in your templates. So platform engineers of different organizations, they can use this functionality, and then they can define their own behavior for the HTTP routes. And yeah, so this is how when you deploy some routes to the gateway, OpenChoreo control plane has some built-in mechanism to resolve the invoke URL. So this URL will consist of 4 different parts: the scheme, host, port, and the path. For the scheme, we use the scheme that the developer has defined in the workload. And for the host, we refer it from the data plane. Like in the previously, I explained that you have to register the gateway, and when you register the gateway, you provided some information like the host port and the namespace. And this port is also resolved from the data plane. And here in the endpoint, this endpoint is basically extracted from the HTTP route. Yeah, so this is also one of the main abstractions, main advantages provided by the clustered thread abstraction. So here you can see as a platform engineer, you can define a clustered thread which will have different security policies, different traffic policies of a particular gateway implementation. And as developers, they are not aware of the underlying gateway implementations. So the developers will only see the high level developer abstractions like security, rate limiting, and header modification. As platform engineers, you can define threads and then you can abstract away the complexity from your developers. Yeah, so this is also some of the policy attachment mechanisms defined in the Kubernetes Gateway API. So when a platform engineer writes some vendor specific policy, they can use this target ref, extension ref, and some gateway API vendors use annotations. Yeah, so this is also this is a concrete example of a thread. So here in the thread definition, you can say that when rate limiting is enabled, you can emit this traffic policy in the K gateway. And so like I explained previously, the platform engineers can parameterize these variables, and then the developers who use these traits, they can provide the exact values. Like for example, for rate limiting, the platform engineer can template the max tokens and the like various values in the policy, and then the developer can provide the exact values like 60, like the exact values. Yeah, so this is in the component type also. In the component type, after defining a cluster trait in the component type, the platform engineer needs to enable that trait. So the platform engineer needs to specify that trait name in the component definition. And yeah, so I will I will do a live demonstration on the concept that we talked so far. So I have a OpenChoreo cluster up and running. So here I have deployed this greater service component, and in the greater service component, you can see this. So this component in the Kubernetes resources, you can see there's a HTTP route emitted. From here, you can see the definition. Uh, so here you can see that this gateway, this HTTP route is attached to this gateway default. So in the gateway default, so this is the default gateway that we have in OpenChoreo, like when you install OpenChoreo. And here there are some policies, and I will go to the API section and I will invoke it from here. So this is also one of the new features that we have introduced with the latest release. So here this API is not protected right now, so I should be able to invoke it without any credentials. So you can see now I get a response here. Now as the next step, I'm going to add some traits, and then I'm going to protect this endpoint with some security. For this, you need to click on deploy, and from here you need to create a new release. And in the create release section, you can go to component, and from here you can select this kgateway trait, and I'm going to click on this trait. So here, you basically need to fill some fill a form. So here you have to provide the exact values. So I'm going to enable JWT authentication for this endpoint, and I will configure this max token as 5, and then I'm going to also enable add-in response headers. I will add this X powered by OpenChoreo header here. And then you need to have an endpoint name. For this endpoint, the endpoint name is endpoint 1. Yeah, click on it. It will create a new release. And then I'm going to deploy that release. So now if you go to this view Kubernetes artifact, so here you can see now you basically provided some basic inputs, but in the release, it has created some new resources like traffic policy. So if you go to this policy, now you can see this is a header modifier policy, and there are a bunch of other policies as well. So now if I go to this tryout section and try to invoke it, now it says JWT is missing. So now I am going to get a token here. So this API gateway is configured with Escadio. So I'm going to get a token from Escadio. So I will do a curl and get the token, and I will copy the token here. And if I provide the token again, and it sends a 200, and now you can see this additional headers that we added from the gateway is there. So now if I invoke this multiple times, you can see this is locally rate limited. So likewise, as developers, you are like basically working with some high level abstraction, and from the platform engineer, you are like defining some threads. So yeah, so that is about the demo. So next, so like currently we have like 7 API gateways we have already implemented in OpenChoreo. If you go to this OpenChoreo ecosystem page, you should be able to see the supported API gateways. And also we do have 2 AI gateways. So these are also like Kubernetes native API gateways. And in these API gateway modules, we also have defined some sample policies like security policy, rate limiting for anyone to get started. But based on your use cases, you can define your own policies. And also, like I explained initially, the API gateway in OpenChoreo is designed to be modular. So if you want to switch the gateway, then you just have to delete the gateway CR that is installed in the data plane, and then you need to install the new gateway controller, and then you just need to do a Helm upgrade to the OpenChoreo data plane and provide the gateway class name. And after that point, if the provided gateway is Kubernetes Gateway API compatible, the API invocations will automatically work. And yeah, so these are some of the complicated routing mechanisms we have in OpenChoreo. So like we support HTTP route, gRPC route, and TLS route. So by default, like most of the samples we have are like HTTP routes. So like those are like those cover most of the major use cases. And if you have any gRPC services, then you can also expose gRPC service directly from the gateway. And for like if you have any non-HTTP services, then you can have a TLS route where you can route to some particular service based on the host name. And yeah, in the default sample, in all of the default sample, we use the path prefix routing. But for any complicated use cases, if you have a requirement to like have regex routing, then that is also possible. So for that, from the OpenChoreo control plane side, we have provided this endpoint resources. So let's say, for example, you have provided some schema in an endpoint, and you can access the resource path from the cell template in engine with these cell APIs. Yeah, that's about it. So if you have any questions, I would be happy to answer.
Thanks, Lahiru. So I'm just going to open the floor for questions if anyone has any questions regarding the sessions that we did today, the sneak peeks, or if there are any other discussion points that we would like to discuss. If there are any questions, please post on the chat as well if you're not comfortable speaking up. So doesn't seem like we have questions. And I just want to thank any community members who have joined, who are contributing to our code base as well. We had a good list of good first issues, and we have seen a lot of the community contributing and taking up these issues and contributing as well to the code base. And also we have got a lot of reach out from the external communities and members who are contributing to various open source code bases as well, to come and contribute to the OpenChoreo code base as well. So that is exactly why we are do in this code walkthrough section, so that we take you through different segments of code that would pique your interest to contribute towards OpenChoreo. So we love to get more contributors into the project and help us build different features. And the discussions, there are a lot of discussions happening under the GitHub discussions of the OpenChoreo repo. So feel free to contribute your ideas, open any issues. We would love to have your contribution and discuss any other features that you all would like to see in OpenChoreo as well. So thank you so much for joining the third community call. For the first time, I think we are right on time to finish the call. So thank you everyone for joining. We will come back with our next community call on the third week of next month. Thank you.